All right, Monday the 17th. This month is going quick. All right, so we're doing the same thing as last time, only this time now everything kind of works. So let's see here. Yeah, I mean, it's the same tasks as before. I did actually want to say, actually, yeah, this works, this works. And then I'm going to do a to-do. And for this to-do, so basically what we want to do is filter on, like, so we're going to do scoring. So score on num lines of text in a group, since we're doing, so we've done text grouping. Here, while we do that, let me bring this up. And just in case something goes sideways, let me rebuild what we've got. Shouldn't have to rebuild because I don't think anything changed, but let's rebuild and rerun, and let's just visually confirm that everything looks good. But I think what we need to do is score on num lines of text in a group, score on let's call it gap size. Well, score on, well, fine. Let's do size of line. Score on size of gap between lines. And then use scoring to help determine if we should proceed to OCR. So currently I was using two methods of scoring. I was looking at flatness of the page, which actually is pretty good. And I think I want to keep that. What are you doing? Why are you... Okay, you should get hub. So that was working. And then the other thing was page size. And page size works fine for some books, but when we had the situation where it's the end of a chapter and we only have, let's say, like the top of a page, well, then that quote-unquote page size would be small. And so then we would say, oh, it's not big enough. It must be too far away to be OCR'd. Again, also like big gaps. This gap isn't big enough here in the image on the right. But if the gap was larger, it would detect this block as one and then maybe ignore the bottom. And again, it would be too small. And then also, like, different books have different font sizes. They have different page sizes. And so what might be good for one book might not be good for another. So I think I want to keep the flatness detection. I think that's been amazing. But I think now, instead of just caring about like how big is this rectangle and using that to decide, really it's, hey, how many lines do we get? Right? Hey, as long as we got like 3 or 4 lines, we can fairly trust that it's actually text worth reading. And then also, you know, when we do that mask, we can actually see, well, let's see here. This ran, right? So what do we got? I can show this better as I talk this through. Yeah, so we have this mask here, and we can measure the size of each of these lines that we detected and decide, like, are they big enough? Like, what is that height there? And I think we could do a metric based on that, and then also the distance between them. So if you take the midpoint between one line and the next line, that'll also somewhat kind of tell us. That might be fuzzier because some books might be tighter. Maybe the gap might not be as big. But that could tell us whether or not the book is too far away or not. Like, can we yeah, I probably, let's assume that that's a bad idea. The gap between lines probably doesn't matter. I would say score average width. Score average width of lines. Let's say trim off bottom 20%. You know, because of paragraph start/end and titles, etc. And then we should also probably score. What was the other thing I wanted to score? Oh, sorry. Use scoring to confirm. I could do a bunch of things with this scoring. There may be something else we can do here too. But the goal would be, can we infer that the text is close enough based on the size? And that, at least having that knob and being able to turn that knob, that might be good enough to, as like a better knob, instead of going off of, hey, how big is this rectangle? We're basically getting a little finer than that and saying, hey, this rectangle here, this long skinny rectangle, how tall is it? Maybe I could go off the tallest, or I don't know. Wow, I don't know. There's a number of ways we could do this. So I think that's useful. I think that'll tell us, that and flatness together might be the metrics I actually need to know that something is good enough to OCR. So here's all the lines broken out. And we finally end up here. This is a beautiful example. 36. Hey, we missed some ones at the top there. I may have to tweak a knob there. Yeah, 36 and 39. So that's pretty good, right? Like that, even that number, like the number of lines can tell us, like, hey, that's actually OCRable text as opposed to it being noise in the background. We might mistakenly pick up something behind the book. I've seen this problem before, especially when I put on the headset and I'm looking at a computer screen. It'll pick up things in the background and say, like, oh, that's something worth OCRing, and it's really not. Again, the filter for page size and flatness, I think, helped to, well, specifically page size, help filter those out. But now with this mechanism, we can actually just say, like, look, we've clustered them together. This is a page, that's a page. So when we do so we end up with a mask on that. Ooh, so we lose some things there. Oh, or is that the old stuff? Okay. What I'm going to start with. So that's all well and good. Before I do any of this, before I waste any time here, what I need to do is confirm that this isn't absolute garbage performance-wise. Because if it's terrible on the performance front, we just probably can't do it at all. So if I bring this up here, what are we calling? Find text regions line detection. Yeah, so it's this logic here. So I'm scaling it down to 75. I may want to remove this. This actually is probably hurting quality a little bit. I didn't think it would. I thought we could go small enough. But now that we're actually trying to detect individual lines, we may not. Like, I had this at 50%, and I had to move it up in order to handle one of my test scenarios. Grayscale, canny edges, those things, bunch of stuff. So it's also hanging. Where is it hanging? Because I can't have it hanging. All this stuff. Filtered lines. Now here's those averages. That debug logic. I think I can delete that. Wow, yeah, so we're doing a lot of stuff here. And hopefully it's all fast. Well, okay, I can actually see a little bit of this here. hold on, we're finally down. Yeah, so final text regions, and then we hung. We got hung here. So what are we even seeing here? So when I run this locally, which is going to be so much faster than the headset, so I'm going to have to run this on the headset to be sure. But 21, half second later, we're at 22. Where do we start here, by the way? Where's our first debug image? Because that's already, if that's true, that's not the best. Here we go. So downscaled. Here we are. Okay, so we do down so... Okay, so basically 2300. We'll start there. 23.0. By the time we're done, it's a second and a half. So on local, it's taking a second and a half. That's with writing images to the file system. So it's possible all that time is that. And if I look at how I'm calling this, blah, blah, blah. Okay, so it's just find text regions. Let me just grab this just in case. So the way we test this is we're going to do a log. We'll put this here. Put it there. Starting old method. Done with old. Starting on new method. Done with new method. There. So now we build this. We put this on the headset. We're not going to use these results, so we shouldn't crash. But we should be able to see what is the timing difference between these two. Now, the one thing I will say, should do this. We add a log statement here because there's a chance, because we already have these metrics already computed up here, we might be able to get rid of this get best page logic. I'm guessing this is fast though. This seems fast, right? Because all we're doing is some contour areas. It's probably fast. Done determining best page. All right, let's save that. So now I'll be able to see, like, yeah, how long do these two take? And as long as this is close to being as fast as this, there's probably some junk in here I can throw away, and I can optimize it a little bit. But if it's like twice as slow as that, you know, I might have to have a discussion. I don't think I'm worried though, because really, like, OCR is the slowest thing here, and chances are this is going to save us from doing unnecessary OCRing. Yeah, like the one other thought I had is right now I'm taking effectively like the outer block and I am chopping it into somewhat arbitrary chunks with overlap, OCRing those, and then stitching them back together by detecting, like, there's duplicate lines. So like the first chunk might end here, but the second chunk will start up here, so that I can find the lines that are overlapping and stitch them back together. But if I'm able to do line level detection like this, where I actually know which line it is, I might be able to just say, hey, get me a crop of the first 3 lines, mask out, like, and then use the mask even to, like, white out anything that's not that. Like, make anything that's not that disappear. Then binarize it, then OCR it, and then stitch them back together without actually stitching back together. So unless this is like 10 times slower, this still might be the better path to go down. Yeah, actually, that's going to be tough. So I'm guessing even if it's slower, I might have to make the decision to move forward with this new approach anyway, because the speed boost I get from it, like the slowness here, fine, because everything after it's going to be faster. All right, well, anyway, let's just see how it is. So if I run that test scenario again, it's going to build. And come on. And I will run the whole test suite once for the heck of it, which shouldn't take too long. Wow, that's going real slow. Something's wrong. Well, I gotta build anyway. So let me just build them both. There we go. Something got hung up there. It was stuck. Okay. This is going slow this morning for some reason. But I might as well get set up for casting. And let's see here. I need... Yeah, let's force stop it. Not that it matters. I don't think it's on there anyway. Wow, that's slow. Alright, let's run the whole test suite, but we'll skip building. While that runs, I can send it to the quest. Yeah, we'll put this up here. Logs will be down there. Casting will be... Yeah, actually, that's probably what we should do. Because then we can have this for me running commands, what the VR headset sees over here, and then down here will be logs. Test suite's doing its thing. Everything's going to take a little bit longer just because it's got to do the other approach, like both approaches. And it's the first time of the day, so the build always takes longer the first time. Wow, this is slow. This is not usually this slow. But let me look at Shaky. Let's see how that did. Here we go. Okay, so starting the old method. So that took like 0 time. I mean, we're talking not even 1/10 of a second. Like I don't know, I forget what that time difference is. It's negligible. And then the new method finished here. Ugh. Okay, so that took 1/10 of a second. So it is 10 times worse, but I think it's okay. It's still pretty fast. Did this finish? There we go. And everything failed because I think everything took forever for some reason. Maybe because I was doing this build too. Alright, let's do the permissions. And just to confirm I can do it, let me do the casting. Let's see here. Hold on. Yes, and... Oh, there we go. Okay, so that is pretty easy. Maybe I should do that more often. For whatever reason, like the link software for Windows just doesn't work. All right, cool. So let's go back to the app. Go find a book. Have a book. This is page not flat. Not that it matters, I think we're done at this point, right? Hold on, too far away. That shouldn't be the case. There we go, processing. I guess it's probably taking twice as long to do the scanning because I'm doing 2 different flavors of it. Well, it might even be 10 times slower right now. Wow, the OCR is slow. Okay, there we go. Okay. Fair enough. Now, let's look at those logs. Oh, see, we're always going to be casting, right? So I could just do that. Okay. Wait, what? Oh. Duh, confirm. Alright. Let's force stop the app and then let's take this here. Okay, so here is the resulting text. Here's our chunk processing. Here we go. So here was our iteration before we started doing everything. Okay, here we go. So starting on the old method. Oh, that's okay. Well, it definitely took longer. So we're talking 30, 60, so half second. No, not a half second. Like a half of a tenth of a second. And then the new method took oh wow 9, 10, 3 seconds. 3 seconds. Ooh, that's a problem. Now what's interesting is everything came before these 3 logs. So I could maybe see what step is killing us? And is it a step that's absolutely needed? Where do we log that? All right, so let's do step by step. Let's do it. So we'll do this here. All right, fine. Let me just do save debug. Why am I not typing this morning? Image. Okay. I'll just drop one for each of those. See, all this takes a bit, right? This is all fast math. Fine, I'll add one here. There, I'll add one there. There. Okay, there we go. And then I can go back up. And we'll do big for loop. See if we can narrow down exactly where we have our problem. Okay, and we'll build. I may have to care about this. Okay, so yes, this could save us tons of time. So one argument could be 3 seconds is a small price to pay. But this is 3 seconds that we pay constantly over and over again. So if it truly takes 3 seconds, that's probably too big of a price to pay. Darn it. Okay, well let's see if I can eliminate a step. There may be steps that are just not needed. But it looks like it's really the... Yeah, it's the stuff that I just logged. Okay, fine, whatever. Okay, that's done. Let's run it. Bring that up, and we'll bring casting up. Sorry, I just had to do something real quick. All right, so that's still deploying. Permissions. Let me see how quickly I can do casting too with this new method of casting. Come on, deploy, finish. All right, headset on. There we go. Why is it not letting me? There we go. Cast and web and go. All right, and let's see. There we go. Processing. And at this point, we're already done. I can actually pack it in because we'll have the results we need. Yep. Alright, that's actually pretty quick, other than the fact that every single time I do casting, Meta asks me, how was my experience? Thumbs up, thumbs down, or dismiss. It would be nice if I could tell it to just go away. Alright, let's see. So, okay, so that's the alignment. Okay, yeah, right. Here's all of our log statements. So, here's where we start. Done with old method, start a new method. Well, downscaling alone takes 1/10 of a second. Edges takes 1/10.5. Horizontal edges takes 1/10 of a second. That takes no time, no time, no time, no time, no time, no time, no time. Done with new method. Oh, I'm sorry. I am looking at the wrong thing. Forest for the trees. We finish with horizontal edges, but then the all components step takes a whopping 2 seconds, like 1.5 plus, almost 2 seconds. No, 1.5, call it. So all components. Whatever happens right before you, you're the problem. Well, that's good. At least it's one issue. So it's literally this step. This is the step that is garbage. Let me see here. So I have the visualization step. I don't think this is the problem. I'm going to assume it's this, but do I need it? I do. Num components and the stats. Like, all this. Because that's the statistics. Labels, fine. Centroids? Not used, right? But stats get used. Yeah. On the off chance that this is the problem, I'll comment that out. But I'm guessing this is the issue. Connected components with stats. Alright, I might have to look up this method and see if there's a faster version of it. But otherwise, what is our final time? Luckily, we started at the top of a second. So 2 seconds. Just under 2 seconds. So that's faster than we saw before. 2 seconds, huh? Is there anything we can do to end early up here? Well, so downscaling. took 1/10 of a second. Which is probably fine. Again, I might remove it anyway. Grayscaling, there's no choice there. Edges was 1/10 of a second. More than 1/10 of a second. And what do we end up with here? So like horizontal edges, that also took like 1/10 of a second. So each of these things is taking like their 1/10 of a second. And what that's getting us is, like, this is horizontal edges. All components is the thing that is like really, like, getting to here is the step that is painful. That takes 2 seconds to compute this image. Okay, so I don't think there's any step we can do early. We have to get to this step before we could throw something away. Okay. Well, that runs. Let me go with OpenCV. Let's go research this. I'm also curious about computes the connected components labeled image of Boolean. What? Is that English? Computes the connected components labeled image of Boolean image. Output array is the labels. Stats. See, I needed stats because... Alright, we're done building. No, this is hanging. We needed... It looks... I think we need stats. I don't think we can get around that. But I'll try and see if we can. Why can I not get the... God, I hate Windows. Yeesh. Alright, I'll do another run real quick. This will also give me a decent average of performance. I can take effectively the lowest of the numbers and go with that. Right now we're at just under 2 seconds. And then I can also see if that method has a faster version of it or if there's ways I can optimize it. But this is always the problem with OpenCV. There are some methods that are super fast and like crazy fast. And then there are other methods, you call them, and it'll take many, many seconds. Let's see here. Okay. Casting. Let's see. Really? Are you too far away, or is it just you were wasting resources? There we go. Yeah. You were wasting resources computing something I didn't need you to compute. Okay. Actually, at this point, I don't even need to care. But there we go. Oops. All right, and then if we look at the numbers, see, now this one, it took longer on this top piece here. It took the better part of a second, more than a half second. And then this one, interesting. So that only took, it's not faster, is it? Hold on. Am I completely out of my mind here? I think it's faster. Am I just not doing math? Let's see here. The previous one, 53.2. So 0.7. It took 0.7 seconds to do the old method. This new method, for this page anyway, for this scan, it's basically 54. So 0.2 seconds, but we add another 0.1. So 0.3-ish. So it's faster now. Okay, anyway, I'm convinced that I should continue with this for the moment then. Let me keep an eye on this number, though. I want to make sure that this wasn't a fluke. Maybe it was that. Maybe it was the, you know, if we're in debug mode. I don't think I care about seeing these connected components. I know they're there. So I don't think I need this debug image anymore. So I think I can just leave this commented out and not bring it back. Let's hope I didn't get lucky and that this is actually true, that it's normally this fast. Sweet. Okay, then let's move on to the next step. Assuming it's sufficiently fast, then let me go to my notes. So now we want to use our scoring. So where do I have my example? Let me bring up the example. All right, so this is from my test suite. Okay, so we have the number of lines. We now know they're all different. We're able to group and cluster them. I am curious as to why this up here got filtered out, because then when we get a mask, the filtered lines... Oh yeah, that one didn't get included. The top one did, but these ones up here didn't. All right, I gotta make sure we don't lose those. Maybe it doesn't matter. I'll run the test suite as a whole. Well, you know what? It does matter if my plan is to grab individual lines and send, like, crop on individual lines and send those for OCR. In which case, then I have to get every line. And in a scenario like this where we've lost a line at the top, so as we can see, like, we literally lost 2 lines. These top 2 lines got ignored for some reason. Which I vaguely recall a setting I was messing with where I could get those back. I could make this flexible to not care. The problem is if you wanted to do a mask, because the the goal would be to say, hey, get me a mask that's only made up of this line and these couple lines. And then everything else gets removed, right? And so then we're just getting the lines that we care about. Or I guess it's more of a box around. Okay, so if we go with a box method around those lines. Because if we just did a mask of, if we just use the mask only, we might lose character details. Like, presumably this little nub here is the top of like the letter T or something. And if we just, but the fidelity here isn't the best. So if we just use the mask, we would lose details. We could chunk it up. We've already done that. That would ensure we don't lose details. But again, we still have the problem then of what happens if we accidentally lost a line. So instead, we could take the approach of yeah, I mean, I guess what I could do is a hybrid of like the method I was already doing. So we could take the whole box here. Let's take this bounding box that encompasses everything. And if we were to say, let's chop it into 4 chunks, 1, 2, like 4 equal chunks. And then we would say, hey, find me the, like, yeah, find me all, like, lines that fit within that bounding box completely, let's say. Basically, you want to be able to, like, you don't want to miss any in the middle, right? We don't want to have one that, like, accidentally gets included in one but kicks out to the other. So account for that. But then basically say, get me all that fit within that box. Cool. Then figure out the box that fits all of them, tightly fits all of them. And then anything outside of that gets masked out. All right, I can try to do that. This would really speed up OCR if I can get this working. Yeah, this would save me a lot of time. Yeah, what was this? This was valid line boxes. Yeah, probably don't care about any of that. Filtered lines. For the moment, let's turn off downscaling. It's a cool tool. Let's just go with image. So this should hurt performance maybe a little bit. I don't know. It might not matter too much because it takes 1/10 of a second to compute this, but then maybe we save the time later. But if I do have a performance issue, scale factor. Shoot. Fine. Let me do double scale factor equals 1.0. If we do have a performance issue, turning this off will help me detect it. Because then I'll be able to more clearly see where our performance problems are. All right, so we'll do that. And then I'm gonna have to run this test suite a couple times, right? All right, I guess let me rerun this. Yeah, let's just rerun that scenario. Let me figure out where we lost it. Because we had it here, and then we lose them there. Let me get those back. We may actually get them back immediately, to be fair, without changing any settings. It might be this horizontal strength. Maybe. So that was... No, all components we had it. And then this is the clustering. And okay, so it's during the clustering that we lost them. And I have a couple of knobs I can turn there. So it was... Where is that? Yeah, cluster boxes with counts. Where are you? Cluster boxes with counts. Okay, so we lost it somewhere there. Oh, shoot. Well, because I ran that, we're going to have a lot of extra images now. Whew. Okay. So we've got the original recipe. Oh, Oh, right. Yeah, so the original recipe ends here. This is what it would detect before. It would just do this block contrast method, which works most of the time, but loses page titles and page numbers, and then large paragraph breaks, new chapters. It starts to struggle, although it is quite fast. All right, so this is the new method, the extra crispy or whatever. Interesting. We lose the title this time. We also have some stuff up there. But it's okay, because we're going to go with the two largest boxes regardless, so we would lose those. All right, let me see if I can get that back. This step feels unneeded. Step. Cluster lines by vertical proximity. .75 maybe? Oh shoot, I need to turn. I need to turn you off. Just so I don't like log twice as many images. Okay. And it'll hang because we're not returning the right result. We get a bad alloc. All right, so that didn't help. So what did I have in my commits? I may have had some minor tweaks here that helped things. Let's see. That's test suite. Oh. Right, okay, I fixed the scaling factor. I got rid of the Blurring? Yeah. That might help. Let me turn that back on. See if that does anything. The blurring may help slightly. This is right. This was a whole new method. Okay, so I'm gonna have trouble seeing what actually helped here, because I spent a bunch of time turning knobs, and I don't even remember what knobs I turned to get everything working. And that's partly why here. Let's set this to 1, and we'll run that again, because it'll probably get included as part of some other cluster, like it'll get clustered its own way. And then we did do width similarity, but we got rid of that. We did height similarity, horizontal overlap, and then checked for if it has overlap at all. Yeah, let's just make, I mean, because if I can get this working for all the test scenarios, that would be good. Interesting. So we end up with a bunch of like random little one-offs that got counted by themselves, and funny enough, but it got counted by itself. Probably because of a min width of some sort, maybe. Okay, so it's scoring by itself. So finding nearby lines with similar width. Computing vertical distance. I don't know, if I just go 80 there. And then I forget if this needs to be tuned up or tuned down, but we're basically saying if it's smaller than the threshold. So if I crank that up, all right, let me test that in a minute. I do remember there being something where it was like the combination of these two together I needed to tweak in order to get something to work the way I wanted. All right, let's see what we got. Nope, that didn't work. But let's try it together. So if I go 9580, and we'll run that. So when we look at them all, I mean, I guess like if we, what if I just did like if has overlap only and see what it does, and see like how we would. Like, would we just vertically throw everything together in the same cluster? So that worked. We actually pulled the Hobbit in. So now, if I go back to like 5, So it was the two together. Let's run this again. Just so I can see like what happens when we filter out all the garbage. Hold on. What am I doing here? Drag that over. Cold wave. I have results, yeah. So when we filter out all the obvious stuff, what is that over there? That's sphere. Well, actually I can see. Oh, okay. That worked, and we still get this garbage up here. But that's okay, because we're only going to care about the... We only care about the ones that... I mean, I guess I could go off of size, but I could go with, like, number of lines. That, like, order them by number of lines. These ones both have 39, so that kind of makes sense. If I rerun now... We'll skip, and we'll do new page. Let's run the new page, the scenario that's actually causing us problems, and see how this does there. I do kind of like that it's failing early, so we don't even bother OCRing. Alright, so there's our mask. Ooh, gross. Okay, it's picking up the big stuff. And we're not getting this title up here. Okay. And I'll bet you if I turn these back down, let's go with, let me do code comments here. And 0.95f for Hobbit page losing top lines. Git diff. Where are we at? Scaling factor, sure. Well, actually. Yeah, no, I want to be here. There we go. Okay. So, right, it was 70. And 85, right. What am I thinking? All right, 70 and 85. Oops, where are you? Let's build and run it again. So the line spacing plus height similarity. But see, I also switched to this has overlap. And that may solve part of this problem. This is kind of close to the top there, but... Yeah, see, that fixed it. But again, now we're going to be back to our other problem. What if I bring back the blurring? So we go with image. This is image here, but it should be blurred. And if I run that again, maybe we're okay. So just do a little bit of blurring. the blurring may help us in our lower detection. So let's first confirm that it helps this one test scenario. Or it's, you know, at least okay. Again, there's our edges. Do we not have blurring? Wait, hold on. Oh, okay, right. Yeah, the problem is... Yeah, also in this case, I think I need enough width. Like, I think you could take whichever cluster has the largest number of... see, if I did that, if I went by largest lines, this one would win. But I guess I could say, if you have any clusters that have similar... If I ordered them, well, yeah. Any of them that like are vertically similar, merge them. So find a way to merge these two. They would then be at 25. So then say, okay, and then any other clusters that are of similar width to the main cluster. So that would pick up this one. So then we would ignore that one. Of course, if we ever had like a spine here that was... I guess we could order them by width. I don't know. I would like to get this title up here. But I don't know if that's going to be feasible. Let's not worry about that for now. Now, if I did some blurring, could I go back to, let's do what, 70.0 F and 0.85 F for new chapter. We'll do... Okay. What if I go 75 and 0.9? If we do that, do we still make new chapter happy? I don't want to dance on the line because if I'm dancing too close to the line for the test cases, that means in the real world, there will be scenarios that 100% run into this issue. No, so that's a problem. So we were already close to the line, but now we've included that stuff at the top. Remind me again how bilateral filtering works. Okay, fine. Maybe don't help me. Man, my internet sometimes is slow. Smoothing images. So, is highly effective in noise removal while keeping edges sharp. It's slower though. Interesting. A Gaussian kernel is used. We should specify the width and height of the kernel, which should be positive or odd. Standard deviation. It's good at removing Gaussian noise. So in this case, it makes it, yeah. I guess I don't really want. Maybe I want like a median blur. Which may... But in median blur, the central element is always replaced by some pixel. %50 noise to our image and applied medium blur. Yeah, but this isn't really the kind of blurring I want. I was hoping to just blur it. Let's see here. Blah, blah, blah. Oops, sorry. So we do it. This is just averaging. So I could just do an averaging. Okay, so we could do CV to blur. What if I did that? That's Python syntax. Let's switch it to C++. And I think we would do blurred, end it with semicolon, and we do image here. What are you complaining about? All right, input array, output array, size, k size. Okay, fine. So we just do 5. I think. Really? Oh, CV size. Oh, okay, fine. CV : size, and it's going to be a... What? What'd you just do? Oh my lord, stop giving me info. Yeah, 5 by 5. There we go. Now if I run that, by the way, what kind of sizing are we talking about here? Blurred kernel size. But is there like an intensity? So we have anchor point, border mode used to extrapolate pixels outside of the image. All right, how did it do? Hey, look, it did blurring. And I can actually visually see it blurred this time as opposed to before. But now we lose everything. So let's drop the intensity and run it again. But that means that, like, edges, we don't find really any edges. And then hold on, let me just see what, like, how we did this before. Horizontal edges. Okay, so everything comes off of that mask. If the mask isn't good. So this is edge detection. Got you. So maybe like blurring altogether is just a bad idea. Given this approach anyway. I mean, now, because I dropped it down to 1, it still works, but it does nothing for us, right? It's like the smallest of blurs. If I blur it just enough, well, hey, let's go with 3. Does that, do we get some sort of like, hey, we blurred just enough to kind of help things? Or am I just straight up like barking up the wrong tree? So I guess I could use this to increase crispness. Yeah, okay. I think there's a reason why I just turned off blurring. Just so here we lose details. And we lose stuff down here. And we lose stuff down here even before we... Yeah, so this isn't going to help us at all. Is basically what I'm learning. Cool. We'll go back to image. All right, so blurring doesn't work because that's not the type of thing we're trying to do here. I can mess with these. All right, so maybe then here, let me see about going 80 here and 95. Make it slightly more generous. Actually, hell, let's go crazy. Let's go 100 and 1.05. I just want to see what it does. And if it gets the title, because I think like we were in this situation here where we weren't getting the title. So if it at least picks up this title. Yeah, I want to pick up this title and not pick up this garbage up here. Let's see if we can pull that off. If we can pull that off, that makes this actually makes this more robust and more in line with the kind of thing I need it to be. I wonder if part of the problem is that this is disconnected here. But that should be fine because I have these little bits here. And I'm basically saying like the little bits should be a part of it. I wonder if because this is outside the boundary here. So maybe I can just add like a little error right there. Yeah, see, it didn't help though. Funny enough, like these still get in. So again, I suspect it's because this is... yeah. Let's go back to shutting this down to 1. Let's go 125, 120. Can't imagine like that's gonna matter at all. But let's just take it to the extreme and see like what's actually needed in order to merge that in. And my theory right now is it's gonna be this. Like right now I just have, it has overlap. But that's probably not what I need it to be. So I may have to bring back this more sophisticated approach. Yeah, I was hoping to get onto scoring today, but I guess this is not... This is slightly too buggy than what I want. Like, I really need to be able to get these lines. If I can get the lines, and, like, accurately get the lines, then I can do some really powerful stuff with OCR. If I can really trust those results coming out of this step of the pipeline. Okay, see, they counted as 1 each. But it's interesting that we didn't count this one in. Which is quite interesting. So now that we've done that, what if we changed this to if has overlap? No, I didn't tell you to fill that in for me. And we'll just comment this out. So now we're basically just going to say, look, if there's any overlap at all, include it. That'll tell me whether or not the has overlap check is the reason why these are being excluded or not. That'll tell me that. If these get included right now, then that means I need to adjust the math on these things here. If they're still excluded, then that means they're being kicked out because they don't have overlap. What's so weird is, like that. See, but the thing is, that's a big line there. So what is this up here? Is it like the top line of the image or something? One way I could get rid of this, by the way, is to just say, like, look, anything that's within a few pixels of the border, throw it away, maybe. Yeah, I don't know. I could do a number of filtering things. I have some thoughts. This is just slower and tedious than I'd like. Still excluded, but you see now everything got merged together. All these got pulled together, but those two are still out. They're still gone. So the issue is has overlap. That is our problem. Let me see what else I can glean from this. So the only check is whether or not they've got overlap. Okay, I think I know what I need to do. Let's kill that. So, our issue is not this at all. I think we can go to 80 and 0.95. And that solves it for the one test case that we have. But this new chapter one is still going to have the problem. And I think the way we filter... So first off, this... Let me get rid of that. And let's run this. So we should still... So now what we should see is that we've included the title. We should get this title in here. At least this part of the title in here. But this top one will also still be included. But it's being included because of this stuff. So then I got to fix this logic to basically say, yes, there's overlap, but like this overlap is way too out in left field. Done, I think. Looks like it. All right. What just happened here? They're all getting clustered together as one big thing. Because of it's the has overlap that is fixing things. Interesting, this is now off on its own. Okay, so we end up with like one big box, I think. All right. Huh? Oh, fine. All right, let's reset it back to factory. Okay, so height similarity. I don't think the height similarity is the problem. I think it's just horizontal overlap. Well, I guess part of the problem was when I line spacing. Okay, so I was successfully filtering them out because they were far enough away vertically. I mean, ideally we'd go off both, right? Here, we kill that. And what do we have? Now that we've reset back. Yeah, there we go. But again, like this got merged into here, and those are off on their own. This is 12, this is 14, right. I mean, I know they're detected, right? Because they show up here, they get detected. I guess like this curve here, that gets its own detection. Same thing with this. Gotcha, like this whole like border line here becomes its own thing. Gotcha. Okay, so here is the deal then. It's saying that this line here overlaps and therefore include it. That's the problem we're having. So the top line of the book, the fact that it's off the page, the fact that it's off the page kind of helps a bit, but we'd have a new problem, right? If we had the line of this thing, it would say, hey, there's an overlap vertically. Why doesn't it say there's an overlap vertically down here? I guess because we filtered out by other means. Because we don't say all this stuff is all Interesting. I think we have like a max width on it, maybe. All right, well first let me get rid of some of the noise. Where the hell is that? Fine, let's go 2. That way we can just at least see the ones that are a little heavier. And then how are we filtering out that other stuff? I guess we get horizontal edges. We get connected components with stats. All right, fine. So the overlap to the left. So in this case, we're comparing cluster line to validated line. This whole min-max thing seems weird. So we get the valid line width. We add it to the start X. Maybe I'll have like an AI just code this up for me. Did I have you working on this? Let's cluster on lines that are vertically near each other and have similar line heights. All right, so still having issues with overlapping lines. There are lines that overlap and thus get counted that shouldn't. Really, the shorter line, yeah, the shorter line should fully overlap with the cluster. Starting, let's say 10% before or 10%, or ending. Starting 10% before or ending 10% after the furthest left and right points of the cluster. This will help account for some image skew, but filter out any overlaps that overlap a little and then go way off. Just show me a diff for this change. All right, so it should just be rewriting this little bit. Right, so it's still the overlap left is still the max of those two. Overlap right is still that. We still have has overlap. So maybe that's still useful to have. Right, so this is the logic that I got rid of. Why can't I scroll? There we go. With 10% margin. Why? Okay, there it is. Why can't I scroll? What is... Oh, okay, I see. So you want this fits cluster. Fits in cluster, which makes sense. Okay, so we're still going to keep has overlap. Fine. Let me grab those. I thought I explicitly told it not to give me git diffs. But here we are. And I'm sure there's some sort of fancy shortcut for doing this, but I'll do it the ugly way. All right. So do what? Tab? Tabs are fine? Sure. All right, so what is it doing? We have int max. Oh, okay, so we're initializing it to a big number. We're starting this with 0. Ugh. Now we're doing C line because like we're already inside the cluster min, cluster max. So we're getting the cluster min, cluster max. Fine. Cluster width. And then the margin left and right with like a 10%. So we're taking 10% of the width and moving off to the left a little bit, going to the right a little bit. And then we're saying, hey, like, is it fully within the cluster bounds? All right, this works. Again, like as all things with AI, like it did exactly what I asked, but this might not be the cleverest, most concise way of doing it. But let's give it a whirl. I'll say it seems mathematically correct. So in theory, this would allow us to get the titles merged in, but it would ignore the garbage. I mean, I guess it's possible you could have some vertical garbage above it. That would get included. But this vertical distance threshold should prevent that. Yes, so I should then be able to use this knob up here. What? That clicked on. All right, anyway, let's see what it did. I should be able to use these knobs then to handle other scenarios. Come on, baby. Let's do it. No. What? Oh. Trash. Huh. But why? Why? Fine. Let's go crazy. Let's go 0.3. So we're gonna say 30%. So that's gonna be very generous, but in theory that should that may pick up some bad things, but this will tell me something. If we go back to this, hold on. So yeah, I guess those got clustered separately because... Okay, so before, just having overlap was enough to bring these in. Because we were just looking for has overlap, These got pulled together. And then these also... Why wouldn't... Oh, because maybe 10%. This is more than 10%. All right. Maybe that's what's going on. So maybe just some gentle tuning is enough to get it to work. There we go. So that works. We get some extra noise. We get this garbage here, and now we've pulled up garbage to the left. But we still didn't... God damn it. We still didn't get the title. Why? Okay. Is it the max line spacing? Let's go 120. Let's go crazy. Like that should... We know they have similar heights, right? So the height similarity threshold should be fine to say that this is similar to that. I mean, heck, for heck's sake, we picked up this nonsense over here. Like, that is a lot bigger height-wise than these others. So, if anything, that's tuned too highly. I could probably dial that back down. So maybe it's just not the vertical height is a problem. Still no. What the hell? Huh. If I go 100 on that. I mean, let's just be practical and do that. But now I'm really lost as to why we can't pick up. I mean, it's there. 20%, by the way, is going to be like that much. So we would go over by 20% to the left. 20% is probably too aggressive. I mean, 10% is probably good. But like 10% should be more than enough for us to pick up these things up here. But we just aren't. I guess I'm annoyed, but I shouldn't be mad, because as long as it fixes things enough. Yeah, see, it's a little bit too much because we're picking up some garbage here and here. So let's go with 10%. Let's bring this back down to 80. And we'll go with 95. Height similarity threshold. That feels too much. I guess I can play around with this, see if I can drop that number. But, okay, let's ignore that stupid title for the moment. It frustrates me, it annoys me, but maybe I don't need to care unless I'm being truly... I kind of want to care, though. Again, if I can get literally every line on the page reliably, then we can do some really powerful stuff. Now, see, we lost things a bit because the overlap isn't enough. There isn't enough of an overlap with the cluster. Okay, so that's fine. I think I can do 1.5 here. That should be more than enough to pick up those things without picking up the noise. And let me run the other test cases to make sure we didn't lose anything. Yeah, I don't think I'm going to be getting to Godot much today. Other than maybe quick build to run on the headset. Let me check these errors. Was there anything I needed to care about? This obscure texture, I don't even know where it's coming from. And then this integer division I don't care about. Alright, cool. Alright, that's done. Let's see the result. Interesting. Just a little bit of that extra 10%, and all of a sudden we get a fingernail off to the side here. But we didn't pick up this guy here. Oh, but we lose the title. Ugh. How'd that happen? We did, in fact, have the title before, right? Yeah. We got title before. Here, I'm going to keep you in reserve because you're clearly a good tempo. What about the previous run? Previous run was too little, right? Yeah, it was. And then, like, 2 runs before? When did we lose the title? So we had it several runs ago. All right, that's fine. I don't know. Let's go with 1.2. Just to see what happens there. And then this, I don't know, let's go 90 on it. Who knows? Maybe because, maybe I just didn't visually notice, but maybe, even though I said that it needed to only be 70, maybe it actually did need to be, or maybe the line height similarity? I don't know. That seems weird. Like, this was definitely working before, as is. Although, maybe now the overlap logic has a problem. Here we are. Now, see, we lose it. Why are we losing it? I'm losing. I'm about to lose it. Has overlap. Fits in cluster. Let's go back to has overlap. Heck, let's go back to 80 and 95. So now effectively we're going to ignore all the new logic. And let's see if we can get ourselves just back to this. This is what it should be. We're just looking to... see, the new thing doesn't even... The new bit of logic doesn't even fix this problem. So if this works, why wouldn't I just stick with this? Oh, because we have this top line problem. Right. That's why. Right. Okay, so that works fine. We do get the title up here. We just also get this junk up here. Which means when we... So this is fine. When we do this fits in cluster bit, just doing that is going to yeah, it's going to do something like this. Let me analyze this for a second. Okay, so we're saying that the smaller line has to fully fit inside of the cluster. But what if we do an OR here? That was an AND. So we're saying the cluster bounds. This causes a new problem. But at least I think I know what the issue is going to be. And how to address it. Here, actually, let me bring up this trash example too. And let's keep this around for the moment. As an illustration of what I need to fix. Here, we'll do that. Bring that over here. You also can go over here. And now we have our new version with the OR logic. And now everything's included. All right, so OR is not going to do it for us. So I think the problem is over here, we're saying AND. So the, like, of the smaller line, all of it's gotta, like before we were saying, hey, look, as long as there's some overlap, include it. And that worked fine. As long as there was some overlap, everything got included. But now we're saying, like, the smaller line has to be contained within the bounds of the larger line plus or minus, like, 10%. And that means in this situation where I guess the problem is that we end up with these gaps here. One thing I can try. Okay, so this ampersand. This has got to be ampersand. So, well, one thing little hack I can try real quick that might fix this. Is let's go to 19 on this. I remember this caused a problem in previous testing. But who knows? Maybe it'll be okay. I did go from 15 to 19. I probably should go to 17. I think it has to be an odd number. Does it? Hold on, what do you say? I'll try like 16. Because I just need a little bit, right? I need a little bit to blur those things together. Let's see how this test ran. So that didn't seem to do anything. Let's just crank it all the way up to 31. Let's see what it does. We should see lots of horizontal lines. When we crank that up too much, we should start seeing like this over here connecting in with this, which is not good. But we should start seeing more horizontal merging of elements. I would expect to see these close up, and I don't know why I'm not. But at 31, we definitely should. But I think that causes new problems. So we'll just have to be a little sensitive to it. But in theory, it could just solve this problem. Am I done with coffee? Let's see here. Yeah, let me go to water. Is the build stuck again? Yeesh. Okay. $57, right? Okay, so that actually worked in a way. Oh, interesting. So 31 did it. It did the thing I wanted to do. It closed these things up. I could have sworn it was too strong before. But maybe now that we're not downscaling, actually, I remember downscaling was causing a problem where lines would merge together, like this would get bridged here, and it would treat them as one big thing, and then that was causing problems. But now that we're not downscaling, that shouldn't be an issue. What is it finding over there? Oh, I see. It's like some fingernail nonsense. By the way, we are doing this before we merge any images. I can't remember. I think the cost of alignment and merging was too high. But one way to improve this even further would be to merge images first. Okay, anyway, 31 seems to do it. In fact, now this got merged up here. I probably might even be able to back it off a little bit, but let's see. Okay, so now it's like too much. But again, we lose the top here. Such a weird problem. I mean, if we just go back down to 0.1 here and run it. So what is this saying? This is saying, so there's an issue here. This is saying so find the cluster's horizontal bounds. We get our min x and our max x. We get our width. And then we add some margin onto. We take the min and we subtract 10%. So this is fine. So it's the cluster width with a little bit of extra added on. And then we're basically saying for our new line, it's x. Its starting x has to be to the right of that margin. So it has to be within the... Okay. It's got to be within those margin bounds. That's what we're saying. For good or ill. And now that we've effectively merged these together, this one gets pulled in with it. Now that we've... Yeah, because that is within... So now we actually could be a little more tight on it. I could probably bring it down from 10% to something smaller. But again, we've lost this title up here for some reason. I think because I think I know what the issue is. When we start clustering, when we start the clustering process, here, let me drop this down to 1. Or fine, 0. Let's go. Which is the same as 1, right? So we'll just display them all, and then I think I can explain this. So I think I know what the problem is. So valid lines is all the lines, right? That's going to be everything you can see that's, well, we do some filtering, but I guess I can bring this back. Hold on. Where is our save debug image? Where the hell are you? There we are. Right. Is debug enabled? That's what I want to check for. I'm going to come down here and we'll do this. Uncomment. Just because I don't want this to affect performance. And there's the not there, so okay, fine. If is debug enabled, we'll log it. And that'll make it easier to see this, what I'm describing. Because we get the connected components, and then we log them all by color. So then when we come through, well, so here we go. So we have our valid, we create our valid lines. And all I'm doing is pushing back, or like here, I'm just pushing back, meaning adding onto the list, a rectangle of all those components. So let's go take a look at this, because I might be able to do some pre-filtering here that solves some problems. But it's not going to solve this problem. So then the issue we have is we have our line clusters, which is initially empty. Cluster. So for each valid line, so we start with the first valid line. I guess well, let me run this while I talk. So I think we're going to, well, hold on. The valid lines is components, and components are, is there any order to them? No, right? We just, the horizontal edges. So I don't know the order in which these come through, but I'm going to guess that they're probably like upper left-hand corner down. So we're going to come through with our first line. It's going to default to false. So we're going to return. So I think we then come through. Oh no, if it's false, we continue. Fine, so we go on to the next step. We initialize a vector. We push ourselves onto it. Then we set true. So the first line becomes part of a cluster. Then we do it again. And we loop through everything again. But here's the kicker. So the first line, we check assigned. It's already been assigned. So we skip all this. It's already been part of a cluster. So then we go on to line number 2. And we say, hey, line number 2, we're going to compare you against a cluster of a single line. and decide whether or not you belong there. So this logic here, a lot of it was assuming we already had a cluster of a bunch of lines. But I need to think about how this applies when we have a cluster of one line. That's my problem. So we may start with like this line here, and we'll put that in a cluster by itself. So here's all the components color coded. That is this here. And then we're going to start clustering them. And so I imagine we'll start with this one. And then we'll, with this one, then we'll loop through all of them to decide if any of them should be clustered with it. That is a expensive operation. I might be able to do a thing like a short circuit here. Like if we can't, like how are these ordered? Like figure out what the ordering is, but I might be able to do some sort of thing where like, hey, if we can't cluster anything within a couple of checks, stop. Also, again, like if I can do something logical here to filter things out. Yeah. The problem is it's going to be tough to like filter things out. Because you could say like, hey, these are too short, but you know what also is too short? This is. And that's too short. I mean, that's real short, right? But I do care about it. Like page number, that's super short. So just based on the XY, you know, baseline shape, I don't know if I could really like filter anything out. Sorry, did that finish? And was I gonna look at something? Yeah. So yeah, we probably get with this. Which means like when we look at this here, we're looking at it from the perspective of these other clusters that have already shaken out and are asking ourselves, does it belong in that cluster or does it belong in its own? Which means when we look at this one, we're deciding, does it belong in this cluster with its parent? Or is it too far below it? And hence why we end up with this kind of thing. So here we said that this was a cluster unto itself. And when we looked at these, they didn't fit in. Now, if I made this wide enough, if I went with like, shoot. I mean, I could, I don't know. I mean, this also explains why this doesn't get added in. All right, let me think for a minute. To decide that two things belong together. I mean, again, I could do the or. Well, I guess I could say, like, look, either its start. See, if I go with, okay, if I went with its start needs to be within 10% of the start, or the end has to be within 10% of the end, that would solve this case. Because we could then say, like, look, the startx here is similar to the startx here. Merge them together, they're now a cluster. That would solve this. Well, I guess for this one, yeah, that would solve this. That would also solve this. It would not solve this title here. I guess I could say either the startx is within or it's okay. Let me try that. So we would say now that I've tested, let's make a small tweak. One of three things needs to be true. Either these, well, hold on. Because what happened here? Our problem is going to be this line is going to be this is the cluster of 1, and this is going to be compared to it. Its startx is not, yeah, see, I can't say wholly contained. Okay. One of four things has to be true. Let's just go with that. Either the startx of the new line is within 10% of the startx of the cluster, or same rule, but for the end of the line and the end of the cluster, or either the cluster's start and end are fully within the new line, or the new line's start and end are fully within the cluster. Please provide diff only. Diff should not be a git diff, but something I can easily copy and paste. There, fine, do that. I gave some real crappy logic there, so let's see if it can follow. I said not a git diff. Okay, well, you suck. Okay, replace our fits in cluster check with the following. Wait, what? Where are you not? There we go. And again, I'm going to have to do... Oh, you want me to delete this. Got it. Fine. I told you not to provide me a git diff. And then this all has to be tabbed in. Fine. Cluster width. All right, so probably do star that and then slash star. But cluster width is still computed, still needed. And the min-x is still needed. Okay, fine. So here we go. Line start, line end. Fine, good. Good idea to recompute those anyway. So our start line is the absolute value of the cluster min-x, which we found. So we subtract them and get the absolute value. So that's sort of like the distance between these two numbers. And then we're just checking to make sure that seems wrong. Yeah, I mean, this needs to be... I mean, fine. Like, this is one way to do it, to say it's within a certain amount of the cluster width. The problem is going to be when we look at this, right? Like, the cluster width could be something like this thing here. So 10% of that is nothing, right? And then you're going to say this is not... I guess that's fine, because we're also then going to say that should come out in the laundry. Maybe this is okay. I mean, I guess once we have enough elements in a cluster, but like 10% of the full width would be... All right, I'll probably just change that. I can't just hard code that though, right? Shoot. I got to anchor it off of something. And the only thing we got going for us is... I don't know. I could go by line height. I mean, that's something, right? Damn. How am I on time? I'm like running out of time so quickly. Coding for 2 hours and then... I do need to stop soon. Okay, I got to stop in the next 10 minutes. Let me see if I can figure this out, though. Let's leave it for now. So if they start near each other or if they end near each other, that's good. And then cluster within line or line within cluster. Fine. Okay. You know what? Fair enough. Other than a little bit of shitty calibration, that should be fine. Like, this seems a little bit dumb, but I'll fix it. That built quicker than it should have. Maybe I didn't... Oh, did I not save? I probably didn't save. Let's build again. So going back to the other scenario, yeah, so if it's a small little like page number or something and it's starting with a page number and that's super small, well, it'll be fully contained within the new line beneath of it, so it'll say they're part of the same cluster. Which, you know, that should be fine. Let's see. Did we actually get what we want out of this? Oh, did we? That just straight up worked. Nice. Still got a little noise here. That's fine. Okay. Oh, shoot. Wow. Okay. Let's see here. Let's set this to 5, and let's go down to 0.05 on that. I don't know, 0.05. Let's run that again and see if we get a cleaner look here of this working. And then does that mean then what I need to do, I haven't been doing this enough, is I should pull these knobs. If I got knobs to turn, I should be tuning these. I should at least at a minimum bring them to the top of the function. Maybe even make them arguments that I pass in. But at least be able to have the knobs up here, turn them, give descriptions about like what they affect. And then later then I can come in here and mess with them. Usually though I find once I get these things tuned in, I don't need to mess with them again. Alright, let's see a cleaner result of this. So there's all the lines, and then there we go. We've got 8. We're within... I mean, again, I can merge these two together. Yes, we've got the title there. We've got all the titles there. Heck yeah. Okay. Let me go with... Okay. We'll do -S, skip the build, and just run it fast. I want to end streaming in the next 10 minutes, just because I have some things I need to do. Other work I need to work on. Alright, so this is our other book. Let's see, does it perform well here? Hell yeah. That looks real good. All the lines are there. For some reason, those got merged. They shouldn't have been. They don't look like they're touching to me. They got color-coded differently. Ooh, these got merged. Okay. I may need to... Maybe I could do a little thinning. I may be able to do a little like line thinning when we do that. But that seems... No, these are purple. Yeah, there's the bridging. There's some bridging... Where is it? Does that count as bridging? I don't see them touching. But the color, I mean, it must be. The color is saying they're both purple, so it's saying that they're the same. I guess that's fine. Worst case scenario, with a little bit of accidental bridging like that, when I go do the cropping to do the chunking, I might end up treating them both as part of the same chunk and force it. Damn, that looks good. Okay. What else we got? Let's go shaky. Come on, shaky. And then who else do I got that we can run? So left and right looks good. New chapter looks good. Shaky and then angled. See, this is a problem. This is the one where, because we've got too much horizontalness going on, it's going to kill us. Absolutely kill us. Okay, the fix for that is, let's go back down to like, I don't know, 25. And let's run that again. Hopefully we don't need that much of it. Actually, the new logic, we might be able to take that back down to, I think it was 15 that it was set to before, and not have an issue. But let's just turn it down little by little. This won't take long. And confirm that we're getting what we need from it. Better, but still bad. Okay, let's go with 19. I think I remember having to take it all the way down to 15. Like I couldn't do much with it. let me delete a lot of these test runs too, by the way. There we go. That's better. 19's good enough. So this is also an older book held poorly. But what we end up with is we lose the page numbers, I'm noticing. Let me come back to that. But this is good. This is actually still tight, still good. So let me run. We'll run new. And make sure new still looks good. Okay, we lost some connection here. All right, so I think I'll have to stop there. But I think I've got a couple of knobs to turn here. I don't know. I so much want to keep going. I always want to keep going, but here, max line spacing. Let's just go more with that. Let's do 90 there. And then down here. Let's go 0.1. Let's go back to that. Who knows? Maybe, you know, be a little more forgiving on the left and the right, and be a little more forgiving on the vertical line spacing. Be a little more inclusive. Maybe that's good enough. But with that previous run, this is still good. That's great. We just lose a little bit here. Weird that we lost those. So is the bridging, the weak bridging hurt us. No, that didn't help. Like we're losing these lines because we're saying that the start X is not within. Maybe I can drop this down to, like, again, let's just go to 2. Dropping it down to 2 will help us see visually what's going on. All right, I really, really have to stop in like another 5 minutes or so. Time flies so much when you're just like elbow deep having fun experimenting with vision processing. All right. Yeah, there we go. So those 3 got clustered together. These 3 didn't get included. And I'll bet you anything. I'll bet you anything. If I can get the 3 red here to get included in these 3, that bounding box would get so big that the rest of this would get pulled in as well. So it's start X. I mean, I think I know what I need to do. We got to like 0.2 on this. You know, I could do something like, I don't know. Like, instead of it being wholly contained, I could do something where, you know, to like get rid of those points that are off by themselves. It's like, unless it's fully contained in, it either has to be fully contained or it has to have some meaningful width to it, right? Something like that. I could get a little creative there. Let me see here. Yeah, there we go. That did it. So in this case, like if I can just kill the noise here, like this one being like, yeah, it's within, but really it needs to like get the heck out of here. Actually, let me see. Did the previous run pick that up? So our previous run that had some issues. Yeah. So, and I know explicitly what the problem is. The problem is definitely this. But that's a fun problem to have. That's a fine problem to have, you know? All right, let's rerun these now. Shaky should be okay, I would think. Got some garbage down here. Got some garbage up there. Weird. Why would you be included but the bounding box? Did I... Let's bring this back to 80. And rerun that again. I don't think that had any effect on the other test scenario. But maybe it helps wrangle in this test. Come on. There we are. No, still picked up extra nonsense. Probably because of that, like, 20% overlap thing. I mean, this one definitely. This one maybe not. I think maybe that the color might be coincidental. It looks like these just got clustered together. This one definitely picked up some garbage. Yeah, I can see. Yeah, 2. Fine. If we go back down to 5, make that our threshold, and run it again. But while that's running, let me look at this real quick. So that might be its own cluster. It looks like, I think there's a number there. I think I see up there. That's like, so that should disappear because this is 33. This did pick up this though. And I imagine because when you look at the top here and go pull a line straight down, it's not that far off. And same thing here, the start of this. Okay. Right. So it's gonna bring in, so I've got some problems there. Yeah, there we go. Now the coloring's better. This one on the right's fine. This one on the left's got a problem. Fair enough. And then let me just do skip and run that scenario. So, let's do to do. Shaky has an issue when we are too generous on and yeah, we'll do and. Let's check out Angled. Angled is this trash test, but I think this one's gonna be just fine. And look at that. That looks great. Sweet. Yeah, not even an issue. Like, no notes. So Shaky's got an issue. We'll run new again. New has the opposite problem. Let me confirm. So this is new chapter. New chapter is great, but if I tone it down, it's going to have the opposite issue. And then left skipping the build. Yeah, let's run that. So that's the 4 test cases that I really care about here. Wonder how some of our crappier tests, if I run them, work. Yeah, has no issue. All right, so this is the to-do. If I can make a tweak to fix for the 2 of those, I think then that's good. We're really good. All right, I'm gonna have to stop here. I do kind of want to run our other test cases too, even though they're older tests that I hate and I've thrown them away. Yeah. Yeah, and it really comes down to this math here. So I really just need to be slightly smarter than this, I think. And then we're going to be good for the clustering. Cool. This was fun. Let's see here. As soon as I can get those bugs ironed out, I think we can then just do this scoring and then use that to determine whether or not we OCR something or not. I think this will run reasonably fast. I also think we'll be able to more intelligently detect like sparse text, which is what we're talking about here, and actually OCR text blocks that we couldn't OCR before. And then also I should be able to improve the chunking mechanism to be even faster then, so that should maybe even cut our OCR time in half. Yeah. And then maybe, just maybe then, that solves a bunch of problems with that should solve most of my bugs that I'm seeing with text recognition. All right, well anyway, thanks for hanging with me for those who did. I saw several people dip in and out. And I will be streaming on Wednesday. Have a good one.